known him for a couple of years, probably since he came to Ball State, and he's assistant professor in the Department of English, and he is, I believe, very well trained in quantitative analysis of linguistic text and phonology. He's well published in phonology and second language acquisition. Today, he's going to give a talk about, well, by the way, he's finishing a book. I read part of that. Very, very interesting and fascinating book. And he's finishing a book on data analysis and data visualization with R in linguistic research. And today, he's bringing a topic about optical character recognition and text analytics. So welcome. It's our honor to have Dr. Garcia to give a talk and at this group.
All right, thanks a lot for the
intro. By the way, I want to say one more thing, that is Dr. Garcia and I are planning to record this lecture, and what we're going to do is we're going to turn off the camera. Well, actually, majority of the participants already turned off their camera, and even we're going to kind of, we're not going to show the names even, only the name of the speaker. That's for his lecture part. Once his lecture is done, the recording on my side going to be done. So just so you know what's going to happen. So yeah, I'm gonna. So do you want to share your screen or something, or you want to talk a little bit?
Yeah, no, I'll just do that.
Yeah. Take over. Yeah, feel free.
All right. So thanks for the intro. Thanks everyone for dropping by virtually. It's kind of nice that we can do this these talks so easily now, as John mentioned. All right, so I have some slides here, and I wanted to go over some of the general idea first, and then we'll get to some action using R, right? So the first thing is when we were talking about this particular talk and discussing what we could do in terms of text analytics and so on, we considered web scraping, for example, which is a very important topic, especially now that virtually everything is kind of online in some way or another. But then I was thinking, I've been working on corpora and corpus compilation and that type of thing. And it turns out that a lot of languages are not really well represented online. And so it's not always the case that you can actually do web scraping successfully. I mean, for English and some languages, it does work really well because things are already digitized online. So you don't really have to work too hard to get those data. But for many other languages, it's still the case that you need a book, right? You have to scan a book, or you have to access images that have been scanned from a book or from newspapers, old newspapers, and so on. And so when that's the case, things get way more complicated, because now you no longer have text ready for analysis. You have to kind of work your way through the data and generate the text yourself. And that's where OCR comes into play. We have to use some kind of tool to extract this type of data from images, really. Only after we do that can we actually do text analysis, right? Because until then, we just have images, and it's not really useful for us if we want to extract words and sentences from our data. So let me just go over one example here, and let me just minimize my thing here. So this is really what OCR does, right? We have here a typical, and this is on purpose. You may notice here that this image is not that great, right? I mean, the quality is questionable in terms of, it's pixelated. There's a lot of chromatic aberration. You have some kind of green stuff around here. This side of the figure is a little more pink in color. So what we want to do is we want to scan something like this, and we want to extract, analyzable text from it. And this is really what OCR does. And you may have already done this before. There are different apps that do OCR. There are websites that do OCR for us. Usually good apps will not be free, not necessarily open source. Adobe does this. Adobe just takes a little longer. Adobe Acrobat is usually very slow processing this type of data. So there are multiple ways of doing this, and OCR has been around for a while, but it's kind of difficult to find the tool that will be the most accurate or accurate enough. So there, not all OCR options out there are equally good or equally accurate, and accuracy matters, right? We want to be able to extract text as accurately as possible. We don't want to have to manually change every single sentence just to correct, lots of mistakes. So this is one ideal scenario where we have the text over there in an image, and we extract it, and it looks pretty good. It looks 100% accurate, even though the figure is far from ideal in terms of its quality. So this is just a very simple example of what OCR is. Now, of course, there are many challenges here. So the technical aspect of OCR is really complex because you can already understand why. I mean, there are different typefaces, there are different scripts out there, different languages will use different scripts. Sometimes you have italic, sometimes it's bold, sometimes there's, parts missing because the text is super old. Or sometimes we just, have this type of image that was scanned, I don't know, 20 years ago, and the quality is just not good, right? Not to mention that when you're scanning a text, even if you use a proper scanner to do that, most of the time, if you don't want to ruin the book, the text will be angled, right? So we already have a lot of apps out there that use different techniques to straighten the text. So if you use Dropbox, for example, there's the scan document option that Dropbox offers actually does that automatically. It tries to kind of straighten the text a little, and it has auto cropping, for example. So it tries to prepare the text as well as it can, right? But anyway, it's still one more level of complexity that we have to add to our task here. Sometimes we'll have a pretty noisy image. The one that you see here is actually pretty good. I mean, considering what you can find out there, the image that you see on the slide right now is actually not that bad. First of all, it's straight, right? So it's not angled, which is already very good. If it's angled, the algorithm makes more mistakes. So this is just one of many, many challenges when OCR is involved, really disentangling all these things. So the sentence that you see here is from the Italian language, which is a heritage variety or dialect spoken in southern Brazil. I come originally from Brazil. And so in the 19th century, a lot of Italians and Portuguese and Germans immigrated to Brazil, to South America more generally, but especially to this region in southern Brazil. And so they brought with them their own language, which was the Veneto language, kind of related to Italian, spoken in northern Italy. And this language kind of developed as a dialect or a variety in southern Brazil. And the reason I'm using this is twofold. The first one is this is a project I'm involved in right now. So we're working on creating a corpus of Italian, and you can already anticipate how hard it will be to find data because it's far from being a mainstream language online. And the second reason is we can't really do much web scraping here. Again, given the first reason I just mentioned, right? There isn't a lot of material online on this particular language. So OCR here is almost a necessity, really. And so that's where this sentence is coming from. It's coming from a book that is, I don't know, maybe 10, 20 years old that was scanned. And this is just a tiny excerpt of the book. Now, I mean, it's kind of intuitive why we would need OCR, right? Again, not all texts are digitized. Most languages, as I said, are underrepresented. You know, it really, in terms of percentage, very, very few languages are well represented online and in digitized text online, considering that we have, you know, over 7,000 languages out there, depending on how you want to count them. So Italian is just one example, right? We don't have so much. So it's kind of an important tool for that, also for, you know, language documentation, but also if you want to save and digitize old documents and, you know, old books, etc. I mean, Google has been doing this for a while now. And the bottom line is, if we don't have computer readable data, we can't really perform any type of analysis, right? I mean, we can't analyze an image other than, you know, check its image characteristics or parameters. Most of us already use OCR, even if we're not aware, right? So if you use Google Books, Google Books is this, you know, gigantic project. It's been scanning books for a while now, but it's not only scanning books; it's also making that image searchable, right? So when you go to Google Books and you search for words and phrases and sentences, it actually finds those excerpts in the library, right? And so that's really important. Otherwise, we would only have images of books. The other thing that a lot of people use that has OCR is Google Translate, right? So we can use the camera, point at something in, say, Arabic, and it will kind of give us the image back with the translation. This has been around for a while now, at least a couple of years, and it's the accuracy really depends on the language. And it depends on the language for a very obvious reason. The more you give data to the algorithm, the more well-trained it will be. So the languages that are most used will end up being the most accurate. And so for English, you know, it's the same thing for Google Translate overall, right? Google Translate is really good for some languages, not so good for other languages. One of the reasons is, you know, frequency, how much language data for that language is out there. But of course, there are other linguistic factors that make translation harder for some languages. Now, there are many OCR options out there. I will focus today on a particular type, one that's called Tesseract. It's an OCR tool, and it was actually developed back in the 80s. So it's been around for a while. It was originally developed by two labs, one in Bristol in the UK and one in the US, they basically worked on it during the mid 80s up until 2005, when they released the code. And so it became open source back in 2005, and then Google started sponsoring it in 1 year later, basically 2006. And a lot of the documentation, a lot of the papers that are written to improve this technology are written by researchers at Google. So currently, the version that we have for Tesseract is 4.1.1, and you can see all of this online. If you just Google Tesseract OCR, you will probably see the first result will be their GitHub page. And so their GitHub page is a repository. And so in this repository, what they do is they have all the code there. They have all the data that's needed to operate it. They also explain how to use it. So, and that's why it's nice to have an entire repository for this, right? You can kind of have access to the entire text, to the entire data sets that they use to train the algorithm and so on. So this is what we'll be using today, and I'll get into more detail in a second. All right, so there are many ways to use Tesseract. We can use Tesseract to use in Python. We can use it directly from our terminals. If you use Mac or Linux, you are probably, if you use Linux, I'm pretty sure you are already using the terminal for several tasks. If you use Mac, maybe, but you can definitely use Tesseract directly from the terminal. It's not the most intuitive way of doing it, but again, it's the terminal, right? So it's pretty effective and it works really well. So that's one way to do it. We are going to focus on R, and part of that is because we do statistical analyses using R already. So it makes perfect sense to try and do everything from within R. there are some, I would say that there's one disadvantage of doing that, but it's not really a disadvantage for R. It's a disadvantage depending on the operating system that you have. And I'll talk about that in a second. But basically this works cross-platform. So if you have Windows, Mac, or Linux, this will work because we'll basically be using Tesseract through R, right? So if you have R and RStudio installed, you'll be able to use whichever you want to basically apply Tesseract and get some interesting results. The second package that we may use, not necessarily it's not necessary to use it. It's not necessarily a requirement to use Tesseract, is this package called Magic. And some of you may know it. There's an app that you can install via terminal called Image Magic, which is very, very popular, especially for Linux. You can manipulate images through the terminal. So it's imagine that this is like using Photoshop, but you can only use your keyboard, right? Instead of having a mouse. So the reason why this Magic package can be useful is because sometimes we want to improve the quality of the image of the file before we actually run the run Tesseract on it, for the reasons I mentioned before. Sometimes it's you have to strengthen the image. Sometimes the quality is terrible. The contrast is not very good. And if you visit Tesseract's website, the repository there, they also go over this. They talk about certain things that you should do to the image if you are not getting good results. So you may already have an image that's good enough, and we'll see that in a second when I move here to RStudio. But if it's a terrible image, you probably want to improve it. And Magic is one way of doing it. You don't have to use Magic. You can use whatever app you are already familiar with, as long as you make the changes that will optimize the process. And these are kind of explained on the website. So I'll basically go over a sequence of steps here, and we'll start, of course, from the beginning. So I will import an image. It will be a tiny image. Then we'll improve its quality a little bit using Magic. Then we'll run OCR just to see what happens. And we'll do some simple tokenization, right? So this will be a very simple text analysis part. So number 4 here on the slide, this is where you could do all sorts of things, right? I mean, if you use Python, you could use NLTK to do a lot of things here. So if you're into natural language processing, this is where that would start happening, right? In R, you could use packages that are specific to text mining, like the TM package. This is where that would start happening, right? But here, I'm just going to do something very simple. I'll just tokenize sentences and words, just to give you an example. And I'll try not to use the TM package, because for tokenization, we don't even need those packages. We can basically get this done with tidyverse. For those of you who are familiar with R, you already know tidyverse is a very famous family of packages. For those who do not use R, tidyverse is basically all we need to perform most of the tasks that we want to perform when we are doing data analysis. So it's a very powerful family of packages that come with dozens and dozens of functions that are super useful. And then finally, I'll show you an example of the corpus that I'm working with a colleague. And so I'll just give you an example of the entire process from the moment that we get the text from an image to compiling the corpus using some scripts that I have. Of course, I'm not going to have time to go over the scripts to compile our corpus. This is just to show you what the process is of the OCR part and the kind of preparing the image part. All right, so let me just change my screen here, and let's move over to RStudio now. So you should be able to see it in a second. All right, so this is RStudio, and I'm sure that some of you have already used it. It's just this nice. It's much better, let's say, IDE for R, right? It offers a lot more than the R editor does. So the first thing I'm going to do here is I'm going to load a bunch of packages. So I'm going to load tidyverse, which is the package I mentioned before. I'm going to load tesseract, of course, that's the main package for today. Magic for image adjustments. And now we're basically done, right? So we only need these 3 packages for everything that we'll do here today. On the right hand side here, you can see what's in my folder. So right now I have a bunch of files here. I have a script, I have a project, a folder for the slides that we just saw, and then I have the image here. So this is the image that I will show you in 1 second. So let's read let's just read the image here, and I'm going to use the magic package to do that. So there's this function called image read, right? And the name of the image is original.png. Okay, so now you can see it appeared on my environment at the on the right hand side here. And let me just show you what the image looks like. So this is the text that we'll be analyzing today. And this is actually where the excerpt from the slide came from. So you can see it's not terrible in terms of quality, but of course it's not great. But then again, this is scan text, it's kind of old, so you wouldn't expect it to be super sharp and so on. So this is part of the job, right? I mean, that's part of what we expect from you know, the OCR here. We wanted to deal with this. After all, if we had text that was almost identical to digitized text, we would probably not need OCR so much, right? All right, so the first thing I'll do here, let me just add a comment. So let's improve image a little bit. So what do I mean by let's improve the image? Let's make it a little more contrasty, so OCR can perceive where the characters begin and where they end more easily. It turns out the Tesseract is actually really good at this, right? The OCR technology here is actually very, very accurate considering how hard the task is. So what I'm going to do is I'm going to create a clean version of the image. So I'll just take the original image. So I'm using this symbol here. It just means next step, right? So I'll just take the original image, and then I'm going to change the contrast threshold, right? So I'm going to fill in some gaps with white, and I'm going to use some threshold here. I'll just show you what this will do in a second. Okay, so this is the first thing I'll do. Then I'm going to change the contrast a little more and sharpen the image. So this is the code here, and next I'm going to change the morphology of the image using this technique called close, and I'll go over this in a second. And finally, I will just convert the image to black and white. Yeah, let's do that. So we will basically make this super contrasty. And I want to reread the image using 400 dots per inch, so DPI. So this will be more, the definition will be better now. Okay, so once I clean this, let me just show you what happened to the image. Okay, so now this is what the image looks like. Now it's much easier to read, at least for us, right? I mean, the algorithm may not care so much in this particular situation, but now we have a very clear image. And here's the good thing about this sequence of code. You don't actually have to memorize this or write this from scratch, right? You can, once you do this for a single image, you could just copy and paste the code, right? You don't actually need to, remember all the details necessarily. You don't even need to do this, maybe, if you get good results with the original image. You may not even have to change this. But this is just something I'm showing you because it is possible. I just wanted to show you this. It is possible to clean the image from within R. That was the point of this demo here. You could, of course, just open the original. Let me show you the original again. You could just basically open the original with any image editor. Even simple apps like Preview can do a little bit of this. You could basically change the contrast you're using your favorite photo app, save it again, and then use the saved version, the new version, to do the text analysis later on. So you don't have to do this in R, but of course there's a huge advantage of doing this, which is you can automate the whole process, right? Imagine you have a folder with 1,000 photographs of text, 1,000 images, right? And you want to do this for every single one of them. Imagine doing that one by one, double clicking, and then opening your photo editor app and doing it every single time, and nobody would have time to do all that. The advantage of doing this via R is that you can very easily write a script that will do a for loop and will pick every single file in the folder and perform the same task, which is what I'll show you later, that I use for the corpus project that we are working on right now. Okay, so this is just improving the image. The next thing we can do here is the actual OCR. Okay, so this is the main part. Now, you may have noticed that obviously, or you may be anticipating this, we have to tell Tesseract which language the data is in, right? I mean, it's not like it will necessarily detect it, right? So we have to first tell Tesseract, look, I'm about to do some analysis using X language. And why is this important? I mentioned before that the more you train the algorithm, the better it performs, right? So it turns out Tesseract already has trained data for over 100 languages, something along those lines. So if you want to do something for English, you can just tell Tesseract, look, use the English data you already have. You've already learned a lot about English, so just apply that knowledge to my text here. So you can basically tell it to use the trained data that it already has. The problem for me here, and for our project here, is that obviously there's no training data for this language because it's not a language that is spoken by millions and millions of people. So we don't have a trained data set, on Tesseract's repository for Italian, right? So we don't have that for Italian. We have that for Italian, which is not too different in terms of OCR, right? So what I'm going to do here is I'm going to load the Italian language package. Okay. Now you first have to install this, but you can easily do that by checking their website. You can install all the languages that they have. It's a simple command that you can run. So I actually installed all the languages. You might as well have everything here. And so what I'm going to do is I'm going to pretend that this is Italian because it's the closest relative that they have. And here's a quick aside. You can actually train Tesseract yourself. So let's say we're doing something for a totally new language that's not a close relative to any of the languages already there. You can actually manually type the text and use machine learning to kind of, it's a very fancy technique. So you can use neural networks to train Tesseract on new data sets, and you can even contribute with trained data on new languages. However, to do that, it's kind of tricky to get that done, right? So you can't do that through R yet. You have to, most of the time it's better to use Linux, not Mac, and definitely not Windows. So it's a little tricky to train Tesseract, but it can be done. Fortunately, you don't have to do any of this if you want to work with languages that Tesseract already has. And it has a lot of languages. So if your language is already there, then you're in luck, right? So I'm just going to load this. So now there's a pointer here saying, look, I'm about to use some Italian data. And so what I'm going to do now is just create this variable which will hold the result, right? And so I'm going to run tesseract OCR. The name of the function is simply OCR, so there's nothing too different here. And then I'm going to use the file here. Let's use the clean version, and then the engine will have, you know, what we specified before. You don't have to specify it before, you could just put it in there, but you can also use multiple languages simultaneously. It may affect the accuracy. So, I mean, imagine that you have a text written in 3 languages, some sentences in one, some in others. It can be a little tricky, but again, it can be done. So once I run this, you can see now I have an output over here in my environment pane, and you can visualize what it looks like by using the CAT function. So we can see here the text coming from the clean image. So let me load the clean image again. So here's the image on the right hand side, and on the left we have the actual text version of that. And looking at this, it's actually pretty good. So if you try and compare them, it's actually surprisingly good, considering that we're kind of using Italian, even though it's not Italian, it's Italian. So yeah, so let's just inspect it visually just to have a sense. Yeah, this is pretty good. So this is a very simple example, and this is how this works. Okay, so you can see it didn't take too long, but it does take a while if you have, you know, multiple pages, right? So it can be a little slow, but it's definitely faster than anything else in terms of OCR that you may have tried, say, using Adobe Acrobat or something like that. So it's definitely going to be faster than that. And later, when I show you the example from the corpus that we're working on, I'll OCR a bigger text, and you'll see the amount of time it takes. All right, so now we have the text here. Now is the time to do some text analysis. So some simple stuff here. We could, for example, create a table where we have the sentences in one column and the words in the second column, and then whatever columns we want to add, we can do that later, right? So one thing we could do here is create a version of the output that's clean. So let me just show you why we need that. If I actually visualize the output here, you will notice that it looks a little different, right? So you can see there's \n's all over the place, which is when you break a line, that's how it's represented here in R, and not only in R, but it's a very common way to represent line breaks. So we want to get rid of those, right? So one thing we could do is go over here and create a version of that that replaces all the let me just change here. We can change everything that's you know, \n. We can change that and replace it with let me write replacement here to be very explicit, and break lines to make it easier for people to visualize. We can replace that with a space, right? So if we do that, we can now see that we don't have \n's anymore, we have spaces. So this is much better already, right? So this is a very simple substitution here, and we're using this function called str replace all. Str stands for string. So if you already use, you know, Python or some other language, this will be familiar. All of this can be easily done in Python or, you know, whatever language you prefer to use, but this is here, I'm using tidyverse just to keep things more consistent. So now we have the text, we have the words and the sentences, it looks good. We can go ahead and extract sentences now. So I'm going to create a variable for sentences, and I think we can do words later. Let's do sentences first. So what we're doing here is basically splitting, right? So we're tokenizing the text. So we want to split the text based on spaces. Every time we have a space, we have a word. And if we want to do sentences, we can look for periods, right? So if we have a period, it's the end of a sentence. I mean, you could add other punctuation there if you wanted, but for this simple example, let's just go with periods, right? So we can do output cleaned. So that's the string we want to split. And then we want to look for a pattern. Now, the pattern that we're looking for is a period. We have to do backslash before period because a period has a particular meaning in regular expressions. So when we use double backslashes, we're basically saying, don't interpret the dot as anything other than a period, right? So if you've heard of regular expressions or use them, that's why we're doing this. So this is going to break the text into sentences, basically. So let me show you what this looks like. So this is what it looks like. Okay, so now we have a list, that's the output, and every single entrance is every single entry, not entrance. Every single entry here is as a sentence, right? So we can basically see the sentences separated from the text, isolated. And because it's a list, one thing that I like to do personally is to unlist it, because I don't love working with lists. So you can just add the unlist at the end here. So now if we run sentences, you can see it's just, you know, the entries individually. It's no longer inside nested within the list. All right, so the other thing I want to do here, I don't know if you noticed this, but some sentences begin with a space, which is kind of annoying, right? And we also have a 9th entry here that's empty, which is also annoying. So let's do that first. So let's see here. Let's remove spaces first. So we can just use sentences. We can do, again, string replace all, which is really like a control F, right? A more powerful one though. So we can look for a particular pattern. So what's the pattern we're looking for? And here's where irregular expressions play a major role. We don't want to replace spaces, right? Because that will basically connect all the words and remove word boundaries. We want to look for spaces that are at the beginning of a string. And for that, we use the hat symbol or circumflex, diacritic, or chapeau, whatever you want to call it. We do that and we add a space. The hat just means beginning of string. So we have beginning of a string followed by a space. I want to get rid of that, right? So I just replace that with nothing, right? So just this, right? So once I do this, I will be able to, let me just visualize it here. So now you can see we no longer have the spaces starting the sentence. So that's already good. And the last thing I'll do here is put this in a table, as I mentioned before. So I'm going to create a table, which is a special type of table. And the first column will be called sentence, which will contain the sentences that we just saw here. And the second column will be called word, right? Now, we haven't created words yet, but it doesn't matter. We can do that here on the go, right? So we can just split the sentences again. So we split the text first to get the sentences. Now we can split the sentences to get the words, because we can just use white spaces to say, look, every time you have a white space, you have a word boundary. So a new word is coming up. So we can again do the string split here. We can string split the column sentence that we just created. And the pattern we're looking for this time is just an empty space, right? Now I'm going to do this first, and then I'm going to show you what will happen. So let's visualize that. Okay, so now we have a table, and the table has one column for sentence, one for word. But you can see that in the word column, below the word column, we have the class here saying it's a list. Which makes sense, right? Because every sentence has multiple words. So there's no way you can fit a bunch of words in a single cell. So what it's doing is inside the cell, it's adding almost like another table, except it's a list, right? Doesn't look that good, right? Because ideally we want to see all the words. the problem is, if we want to see all the words, we will have to inevitably repeat the sentence n times, where n is the number of words. So if you have a sentence with 25 words, for this table to work, we'll have to have the sentence repeated 25 times, once per word. And we can do that very easily by using a final function here called unnest, right? So it's basically, we're going to unnest all the column here, the column called word, right? So we're unnesting it. And the other thing I want to do is get rid of the final line, because I don't know if you noticed, we have an empty line at the bottom here. So we can use a function from tidyverse called filter, and we can just say, look, I want the sentence to be different from empty, right? It has to contain something. I don't want to have nothing in a line. So if I run this now and visualize it, now you can see that we have the sentence in one column and the words in the second column. And because the first sentence has 1, 2, 3, 4, 5, 6 words, here they are, we have to repeat the sentence 6 times, right? So we end up with basically 6 lines for that particular, 6 rows for that particular sentence, right? So from here, we can very easily do other things. For example, we could add a new column called word length that will count the number of letters in a word. We're talking about the orthography, right? So we can just count the number of characters in a string using this function, str_count. So now if we visualize it, you can see we have sentence word and word length, and the word length is telling us how many letters we have in each word. So this is just a very simple script that improves an image, imports the image, improves the image, does OCR on it, uses the output to organize it into a table, and now we are already, we have a tokenized version of the text, and we're ready to do other types of analyses here. This is where, depending on what you want to go from here, you would need packages like, fancier packages like TM, for example, for text analysis. But really, depending on what you want to do, you don't need those packages. So it's more, it's kind of nice that you can do this without TM, because then it's more consistent with the rest of the analysis, right? So this is a simple example. Now, let me show you what the corpus example that a colleague and I are working on looks like. So first, let me share the screen again. Let's go to Safari here. This is the website for the corpus we're working on. This is, again, a language that is spoken in certain regions in Brazil. In some areas in Brazil, it's an official language together with Portuguese, Brazilian Portuguese. So I'm going to zoom out the map here just so you can see where this is. So again, this is in southern Brazil. There it is. So this is the region that we are collecting data from, where this language is spoken by many people. So the corpus is here. This is what it looks like. It has a sentence, a word column. We have frequency, log frequency, the author, where the text is coming from, and the year it was published, right? So this is already outdated because we are going to update the corpus very soon. This is work in progress. So at this point, we had roughly 20,000 words. Now we have 100,000. So we have many more words at this point. So I'm going to show you what the work looks like here for what we're doing, right? So to do that, let me go back to our PDF file here, and let me show you what this looks like. So this is one example of a text that we have that was scanned. Now the quality is actually good, right? You can see it's actually surprisingly good, much better than the other texts that we also have in the corpus. But this is clearly not ready for OCR, right? First, there is a figure in the middle of the text. Second, the page has already, a lot of other things. So the first thing I'm going to do here is crop this image, right? We need to do this. And I'm going to do this all manually, because even though you could write a script to do this, because every single page is slightly different, it would be very tricky to have a computer do it. But so let me just show you manually how this could be done. So first I'm going to crop this image here. So now we have the text that we want to focus on. The second thing I'm going to do is I'm going to get rid of this figure in the middle here. And I'm not even using a fancy, image editor app or anything. This is a very good PDF reader, but it's just that. So I'm just going to erase this figure using my pen here. So this is just so that the OCR is more accurate. If you leave this figure here, Tesseract will still work, but you will have a lot of problems later on, because you will have to delete a lot of weird symbols that it will add because it can't recognize what the figure is, right? So it's just saving you time later, even though it looks a little annoying. It's kind of a manual part of it, right? So if you want to increase the accuracy, you definitely want to do something like this, because images are just a nightmare for Tesseract. And so especially here, where you can see that text is kind of broken into columns, and even within a single column, what's happening is we have this situation where there's a lot of hyphens all over the place because there was a figure in the middle of the text, and so on. All right, so now I'm going to save this. We still have another problem. The text has 3 columns, right? And this will not work with Tesseract. So what I'm going to do is I'm going to create let me just share my entire screen now here with everyone so you can see what I'm doing. So what I'm going to do here is bring my Finder window over here, and I'm going to make sure this is all erased here too. And so what I'm going to do is create 4 copies of this, and you will understand why in a second. So I'm going to create 4 copies of this file, and I'm going to give it the title, of the text here, which is, let's just write part of the text title here. And the author is called Deason, and this is from 2010. You'll see why I'm using this template here. So now I'm going to duplicate it 3 times, and I'm going to order this, adding some numbers at the end of the file name here, just to keep it ordered. The reason why we have to do this is because there are 3 columns, and Tesseract will not be able to understand that these are 3 separate columns. So what I'm going to do here is I'm going to crop again all 4. So I'm going to crop the title first. Now I'm going to crop the first column, excluding the name of the author there. Now the second column. And now the last one. So now you can kind of see why I needed 4 copies, right? If you have 3 columns plus the title. Okay, now this is done. What I'm going to do is I'm going to merge all these files into a single PDF. Here it is. So now all the files are merged together vertically, right? So this is what we need to maximize the accuracy of Tesseract, right? So you can even improve this a little more over here just to remove some additional noise. And now I'm going to save this as a flattened file, and I'm going to put this inside this folder here. That is where I put all the clean images. All right, so this is done. I don't want to save the original, doesn't matter. Now I can get rid of this. And let me just show you what happens with the file. So this is the result. This is the image that we will now work on. Okay, so here we have the title and the text, no figures, all vertically aligned, right? So it's a continuous text. All right, so now that this is done, what I'm going to do is show you what we do for this corpus. I'm going to move on to the corpus script here. Here's what we do. We basically load the packages that we need over here, just what we did before. We set the engine to be, pointing towards Italian, and now we basically look at that folder and look for a file. Here's the file I just cleaned and merged, right? I want to extract the file name. Here it is, right? And I want to remove the PDF part from the file name. That's what this part is doing. And now I have this for loop. And what this for loop does, and this is going back to what I said before, what the for loop does is it's going to read every single image in the folder. And for every one of those, it's going to run OCR, and it's going to save it as a separate text file in another folder where all our texts go. So here is that folder. So this is where all the files are. This is where the file we are doing now is, and this is the folder that will save all the already OCR text, right? So here it is. All right, so let's just run this here, and you can see, let me actually show you this in real time so you can see the for loop working. So here's the text. It should appear over here the moment we run the for loop. So it's converting page 1, 2, 3, 4, and it's done. So now it should appear over here, and here it is, right? So this is the text that we just OCR'd, and you can see that it keeps the hole in the middle where the figure was. So now you have to go in there and use backspace to remove it, or you can write a script to do that for you. I just wanted to show you the manual part 2 that shows how you should help Tesseract by preparing the text in a way that improves its accuracy when you perform the task, right? So this is the text that's being OCR'd, and what I do now is I come back here and I basically make sure that I check the text that I just did by just coming here and say, look, this is done now, right? So I just tag it, right? It was actually at 2011 the year, so I would want to do this again, basically. So this is basically what we do, and once this is done, what we do here is we have an entire script that will put everything together in the corpus. So if I just run this whole thing, you will see that it will take a little while. So it's basically reading all those texts and putting everything together, separating the sentences, separating the words, adding frequency. It's doing all sorts of things here. And at the end, it will just print the updated corpus with this new text that I just OCR'd. And here it is, right? So now we have 104,000 words and 9 columns. Here are the sentences, the word, the sentence length, etc., the title, and the year. Now, this is why when I saved the file, I used a particular template using underscores and hyphens, because the script that I made here is basically going to extract the title and the year and the author using those patterns. So the hyphens are there to separate these pieces of information so we can kind of get them into separate columns when we do the table here at the end of the process. All right, this is what I wanted to show you. This is kind of the two-part process involved in the corpus that we're working on right now. So this is a simple script for the OCR. It's a more complex script for the actual corpus, but it's something that, depending on the packages that you're using, I like to use Tidyverse, you can make your code look much shorter depending on your technique there. And basically you can do this into in two separate steps, right? First, you clean the text and OCR it, and second, you do the text analysis, which is what we just did here. So this is all I have. I think we can now have some questions, Jun.